So, hello everyone again. This is lecture 3 part 3 of communication systems. I am Sameer Lavankar. Let us begin our discussion. So, a little bit course outline for you. We started with introduction of communication system, then we got to know about elements of communication system, that is transmitter, channel, receiver and a channel. Then in the basic terminology used in communication systems, we got to know about what's a transducer, what's a signal, what's a noise, what's an amplification, what's an amplitude, what's a modulation, what's demodulation, what's range, what's a repeater. Then in bandwidth of signals, we got to know what the frequency range is required, why is there a need for different frequency range for different things, why is there a greater frequency range for let us say a videograph or a television broadcast, and there is a smaller frequency range for just a voice signal like telephonic communication and so on. In bandwidth of transmission medium, we got to know about different mediums required for bandwidth, what are the different transmitting mediums for different parts, let us say for television, let us say for ultra high frequency, let us say for low frequency and so on. In propagation of electromagnetic waves, we got to know about ground wave, we got to know about sky wave, we got to know about space wave. A simple problem regarding space wave was also conducted in the last lecture. Today we will be starting with modulation. What's modulation, what is its necessity, a little mathematical formulation of modulation and so on, what's a carrier wave and so on is the agenda of this lecture. Let us move on with our discussions today. So, modulation and its necessity. So, the purpose of a communication system is to transmit information or message signals. As we already know, this was the basic introduction of communication systems only, that the purpose of communication system is to transmit information or message signal from point A to point B. The message signals are also called as baseband signals. So, this is just a mathematical it is a physical definition just to iterate to you that message signals are also called as baseband signals. These are also called as baseband signals, which essentially designate the band of frequencies representing the original signal. What it represents? It represents the original signal only. More about baseband signals will be conveyed to you in the subsequent slides. For now, just understand this part, that message signals are also called as baseband signals, which essentially designate the band of frequencies representing the original signal as delivered by the source of information. Next point, no signal in general is a single frequency sinusoid. So, quite evident that anything which goes from point A to point B is always a superposition of many waves. So, no signal in general is a single frequency solenoid, everything is multi frequency. So, a single signal has a frequency of let us say 4 megahertz, then 3 megahertz, something like this, but it spreads over a range of frequencies called the signal bandwidth. So, every signal has a signal bandwidth. This is the concept in this third point, that any frequency, no signal has a single frequency and it spreads over a range of frequencies called as signal bandwidth. Now, suppose we wish to transmit an electronic signal in the audio frequency range. What is an audio frequency range? Audio frequency range is basically the range which our ears can hear. So, it ranges from a few hertz, 20 hertz to ranging from 20 kilohertz. So, baseband signal frequency. So, what is baseband signal frequency? It is nothing but message signal. So, any frequency related to message signals can be either voice signals, it can be either picture signals, can be music signals and so on. So, audio frequency range is nothing but 20 hertz, ranging from 20 hertz to 20 kilohertz. So, baseband frequency is less than 20 kilohertz over a long distance directly. So, now we wish to transmit this audio frequency, some audio frequency which has a range or which has a bandwidth of 20 to 20 kilohertz. So, approximately 20 kilohertz of bandwidth over a long distance directly as in from point A to point B directly without any disturbance. So, let us find what factors prevent us from doing so and how we overcome these factors. So, when we try to pass this information over a long duration, if we try to increase its range, then it is not directly possible. Why it is not possible? What are the factors? I guess there are 3 factors responsible for this. We will get to know directly and hence we will try to overcome this using modulation. So, please look over the next 3 slides very carefully. What are these factors? So, first factor is size of the antenna or aerial. So, for transmitting a signal we need an antenna or an aerial. Quite evident that the transmission of the wave from a transmitter to a receiver only happens using a antenna. this antenna should have a size comparable to the wavelength of the signal. So, in some of the concepts I already told you that if there is a wavelength of lambda to be propagated from point A to point B, then approximately lambda by 4 wavelength of size of antenna is required. So, this antenna should have a size comparable to the wavelength of the signal, at least lambda by 4 in dimension. So, this is also written here that the size of the antenna should be minimum or at least lambda by 4. What is lambda? Lambda is the wavelength. Lambda is the wavelength, at least lambda by 4 in dimension, so that the antenna properly senses the time variation of the signal. So, that to means the last line just says that for the proper functioning of the antenna or the proper functioning of the propagation from point A to point B, it is required. What is required? The length or the dimension of the antenna should be lambda by 4, at least lambda by 4, approximately lambda by 4. So, now for an electromagnetic, so now it is an example here. So, for an electromagnetic wave of frequency 20 kilohertz, why we are talking about 20 kilohertz? Because we started this discussion why, if we need to transmit a signal of audio frequency range. What is an audio frequency range? It ranges from some some hertz, 20 hertz to 20 kilohertz. So, let us for example suppose that we need to transmit an electromagnetic wave of frequency 20 kilohertz. So, the frequency, so the wavelength of this frequency is 15 kilometers. Now, just suppose that if the wavelength is 15 kilometers, that means an antenna, the size of the antenna, what is the antenna? Antenna generally in the vertical size. So, vertical size is being talked about. So, 15 by 4 is in kilometers, We cannot suppose, or we cannot even think of making as antenna of such a big length. So, this is not possible in real life. That is why we need to do. So, that is why this is one of the factor why this small frequency ranges cannot be directed from point A to point B. So, obviously such a long antenna is not possible to construct and operate. Hence, direct transmission of such baseband signal is not practical. What is a baseband signal? Any message signal is also called as baseband signals. So, hence direct transmission of such baseband signals is not practical. We can obtain transmission with reasonable antenna lengths. And what can be a reasonable antenna length? 300 meters, 200 meters are reasonable antenna lengths, because that is easy to make and construct. It is also possible in real life to construct such lengths of antennas. So, we can obtain transmission with reasonable antenna lengths if transmission frequency is high. So, what is required? Transmission frequency high is required. Quite evident that if the frequency is low, the wavelength is large. If the frequency is high, the wavelength keeps on reducing. If the wavelength keeps on reducing, let us say if the wavelength is of 1000, so 1000 by 4 is 250 meters, and hence this is reasonable. So, if the frequency is being increased as such that the wavelength gets constricted to, let us say 1 kilometers or 800 meters and so on, then the antenna's length can be reasonable and practical. So, this is one of the factors why low frequency ranges cannot be transmitted for the long duration or for long distances. So, we can obtain transmission with reasonable antenna lengths if the transmission frequency is high. For example, if nu is nothing but frequency, if is 1 megahertz, then lambda is 300 meters. Lambda is 300 meters, so 300 divided by 4 is a much more reasonable antenna length. Therefore, there is a need of translating the information contained in our original low frequency baseband signal into high or radio frequency before transmission. So, what is being required? Is this transmission, this low frequency range has to be somehow converted into high frequency range for its transmission. If this high frequency range is being constructed, then it is quite easy to transmit using it through antenna. So, this was the first factor, that is size of the antenna areal. Let us move on to the next factor. So, the next factor is effective power radiated by an antenna. So, a theoretical study of radiation from a linear antenna, let us say the length of the antenna is L, shows that the power radiated is proportional to 1 by lambda square, that is So, this is the concept being told in the first line here, that a theoretical study, when a theoretical study was being conducted regarding radiation from an antenna, it was found that the power radiated, energy radiated is directly proportional to 1 by lambda square. Wavelength is also called as or denoted by lambda. Next point, this implies that for the same antenna length, the power radiated increases with a decreasing lambda. Quite evident that if this is decreased, so energy will be increased at a very higher rate. Why it will be increased at a very higher rate? Because it is inversely proportional to square of something. So, if the square is a factor there, then the energy radiated will be much higher than the rate of decrease of wavelength. So, this implies that for the same antenna length, the power radiated increases with a decreasing lambda, quite easy, and with decreasing lambda can also be realized increasing frequency. In the last factor also we talked about, if the frequency gets increased then the wavelength gets decreased, if the frequency gets decreased then the wavelength gets increased. So, a decreasing lambda can also be supposed with the increasing frequency. So, for a typical proportion, we can also say that with increasing frequency the energy radiation gets increased. Hence, the effective power radiated by a long wavelength baseband signal would be small. So, effective power would be small, and that is the thing we require. We do not require radiation should be much high. So, hence the effective power radiated by a long wavelength signal would be small. So, for a good transmission we need high powers, and hence this also points out to the need of using high frequency signal. Sorry for the last line. So, energy radiation should be high, I misspelt it, energy radiation should be high. So, because of this energy radiation, the power with which the signal will go from point A to point B will be much higher. So, efficiency will be much more. Sorry for the last statement which I said that energy radiated should be less, energy radiated should be more only. Why it should be more? Because we need much power for transmission from point A to point B. So, how will we get much power? We will get it if the frequency is high. If the frequency is high, hence the value of wavelength is less, it will help us in two factors. The first factor also, that the size of the antenna is being reduced and hence the transmission is easy, and the radiation of power is also high. So, increasing the frequency till these 2 points is very beneficial for the transmission. Let us move on to the next factor. Maybe the next factor also is directly linked to high frequencies. Let us move to the next factor now. So, next factor is mixing up of signals from different transmitters. So, what is mixing up of signals? We will get to know in this slide. So, another important argument against transmitting baseband signals. What is baseband signal? Baseband signal is nothing but message signals. Message signals are also called as baseband signals. So, another important argument against transmitting baseband signals directly is more practical in nature. Suppose many people are talking at the same time, or many transmitters are transmitting baseband information signals simultaneously. So, transmitting of signals is being analyzed and is being made analogous to many people or a crowd speaking. So, all these signals will get mixed up and there is no simple way to distinguish between them. Quite evident, let us say there is a full class of 50 students and everyone keeps on speaking, then each clear words won't be heard by, let us say, me. If I am the receiver here and you all the students sitting, a class of 50 students are being iterating some words from their mouth, and because of the noise or because of the mixing up of each of the voice signals coming out of your mouth, the clear signals won't be got by the receiver. Let us say I am the receiver here. So, same thing happens, same analogy can be conducted with the signals also. Let us say there are large number of transmitters transmitting a signal, then due to mixing up of signals, the receiver could not understand or could not get the signal, could not get the complete signal clearly or quite efficiently. So, that is the point being told in the second point. Next point is, this points out towards a possible solution by using communication at high frequencies and allotting a band of frequencies to each message signal for its transmission. So, what is the solution here? The solution we talked here is that, let us say there are a class of 50 students, I say to them that you say in this voice, you say in this voice. So, if the voices are being varied, then it is easy for the receiver to receive the signals. So, similar analogy can be put here also, if I denote for each of the transmitter a band of frequencies, then I will just shoot up or I will just select that band of frequencies and then get that signal received to me. So, this is the analogy being put up here, that if I put a band of frequencies allotting, first of all every frequency should be of high frequency range, and in that high frequency range if I allot a band of frequencies for different transmitters, then the passage or the retrieval or the receiving of that information is quite easy and efficient. So, this points out towards a possible solution by using communication at high frequencies and allotting a band of frequencies to each message signal for its transmission. Hence, there is a need for translating the original low frequency baseband message or information signal into high frequency, and hence this is also required that a low frequency range has to be converted into a high frequency range. Hence, there is a need for translating the original low frequency baseband message or information signal into high frequency wave before transmission, such that the translated signal, what is a translated signal? If it is converted from a low frequency range to a high frequency range, then that signal is known as translated signal, continues to possess the information contained in the original signal. So, as long as the information to be processed from point A to point B is intact in the translated signal, it is efficient to us, it is useful for us, and hence propagation is easy, and both the factors, the below both factors and this mixing up of signal factor is being put into usage, and hence the final conclusion of all the three factors was that if the frequency is being increased and there is a translation of the signal, translation as in from the low frequency range, if we use a high frequency range for propagation, the complete concept or complete factors are being put to use and the message is being transferred from point A to point B. So, this was the fourth point. The concluding point is, in doing so we take the help of high frequency signal known as the carrier wave. So, what is a carrier wave? That for the passage from point A to point B, what we do is we superimpose a low frequency range with a high frequency range, and the passage of information happens, and at the retrieval point or at the receiving point, by using some means we separate both high frequency range and low frequency range, and then using the receiver's propagation or receiver's main device, we recalibrate or retrieve the information from a non-electric signal to an electric signal to a non-electric signal. This is the complete communication concept. So, in doing so we take the help of a high frequency signal also known as carrier wave and a process known as modulation, which attaches information with it. So, what is modulation? Is this concept only, that the propagation or the process of conversion or the process of propagation of a low frequency information signal using a carrier wave. What is a carrier wave? A high frequency signal from point A to point B is known as modulation. So, for this lecture let me stop it here only. In the next lecture we will get to know a mathematical formulation of how a carrier wave is being added or being superimposed with a low frequency wave, and then typically we will get to know different concepts regarding amplitude modulation, frequency modulation and phase modulation. In the class 12th syllabus only amplitude modulation is to be told in detail. After the completion of amplitude modulation, the communication system chapter is completed. So, the course progress after the completion of lecture number 3, lesson number 1 is completed, lesson number 2 regarding transmitter, channel and receiver is completed. Basic terminologies, there are I guess 10 to 12 basic terminologies which was being conveyed to you. Bandwidth of signal, frequency range is being conveyed. Then lesson number 5 was bandwidth of transmission medium is being done. Propagation of electromagnetic waves is also done, which conveyed you regarding what is sky wave, what is ground wave, what is space wave, sky wave, surface wave propagation, sky wave propagation and so on. And finally, today we were discussing about modulation and its necessity. I started with the introduction of modulation, why it is necessary, what are the factors involved in completion or propagation of a low frequency range in larger or longer durations. So, in the next lecture we will go with mathematical formulation of modulation, and finally I will convey to you what is amplitude modulation, and that will be the end of communication systems. So, for this lecture, thank you.